Hi students, today recording the vodcast to homework 3.10. This was taken from the 2000 exam. Um, I believe I asked you to do A, B, and C for this problem. So let's analyze this problem. So I see delta H flying around, so I know that I'm working in unit 3. I do see my little F symbol, so I know that I'm working in the middle of my flowchart in unit 3. So I'm going to be working with the products minus reactants equation. So referring to the data in the table below, calculate the standard enthalpy delta H for this reaction. Okay, so this is the products, this is the reactants, and delta H is going to be equal to the sum of the products minus the sum of the reactants. So let's go here and plug this in. The products are O2, that's a single element, there's one of them, so that's going to be times 0, plus one of the NO2s, and the NO2 value here is 33. Okay, so we did the products. Reactants, O3 is a single element, but it's ozone, so it's a little funky thing there, so it does have a value. One easy way, if they don't give you the value for something like this, then you know it's 0. And NO is 90, there's one of those. So I have 33 minus 43 plus 90, so that's going to be 133. Now we all know what the answer is to that, but let's go ahead and do the calculation out anyway. 33 minus 133 equals negative 100, and our units are given to us right there. Kilojoules per mole. So it's a negative 100 kilojoules per mole. It is spontaneous. Let's go through and double check our work. This side is 33. That's minus 133. So that's going to end up being negative 100 kilojoules per mole. That's exothermic. Make a qualitative observation about delta S. It's got to be qualitative because notice there is no delta S data in this chart. So it's got to be qualitative. So I look up at this reaction and I have one gas, basically two gases going to two gases. So I'm going to say delta S is around 0 kilojoules per mole. It's got two gases going to two gases. It doesn't get messier or clean. So on the basis to A and B, predict delta G. All right, so let's go through and just look at the equation in this case. If delta G equals delta H minus T delta S, and delta H was 0, this whole thing is going to go to 0 because delta S is 0. So delta G is negative. And where could we write this? Let me give you a place to write it. Okay, I'm going to write it down here. Since delta S is 0, delta G equals delta H, thus spontaneous. Okay, spontaneous because delta G is going to end up being less than 0. Okay, so let's go over these answers one more time. Again, we did see the little f right there, so we knew to do sum of products minus sum of reactants. The right side are the, I'm sorry, these are reactants and these are products, my bad. Okay, so the right side are the products, the left side are the reactants. Here are the products, here are the reactants. We plugged it in, we got an exothermic negative 100. Qualitatively, we saw that delta S was around 0 because it didn't get messier or cleaner. Thus, this canceled and delta G was equal to delta H in that case, must be less than 0 and spontaneous.